Technical tips from my boyfriend. Okay guys, in this video I'm going to tell you about the top 6 render settings that you will want to focus on to send your beautiful images into a final movie render. In a previous technical video, I walked through 11 factors to get your images looking as good as film. But now we want to look at the 12th factor, rendering, which will output your filmic images for the world to see. And no, I'm not going to push renders to 24 hours per frame. These settings strike a balance between super fast render times and movie quality renders. What do I mean by fast? In Blender, my laptop rendered equivalent scenes at about 120 seconds per frame. In Unreal, these top 6 render settings produced better results at only 2 seconds per frame. Jump into the movie render queue, click the settings hyperlink, and search in the Plus Settings tab. Delete the default export and jump into number 6, Apple ProRes 4444. ProRes 4444 is an export setting that is a gem of a codec. You'll get compression savings between frames versus the hard drive costs of rendering individual frames. This is for final renders, so we aren't using individual frames for post-processing work. Compression savings will be needed because this setting will be chugging at 300 to 500 megabits per second, which means hard drive space. The fourth 4 in 4444 is an alpha channel. Nice! Anyway, what you get with 444 codecs is visual fidelity that is perceptually indistinguishable from the original viewport. How? Color. 422 codecs create one color for every 2 pixels, whereas 444 codecs create one color for every single pixel. Enable Apple ProRes Media in your plugins for this option. Number 5, deferred rendering. Nothing to change here. We aren't playing a game during cinematics, so we don't need real-time rendering, since we're asking Unreal here to take all the time it needs to produce beautiful movie files. Accept the deferred rendering defaults. Number 4, high resolution. Again, we want to tell Unreal to choose quality over real-time game speed. And yes, the defaults for high resolution is great. Number 3, anti-aliasing. High contrast between light and dark areas with super straight lines can cause jagged edges. Smoothing those edges with an anti-aliasing method will make the cinematic look less like a video game and more like a movie. Each method has its purpose, and oh boy, there is controversy about moving away from using none in some filmmaking circles. But for dispersed lighting, with lens effects like bloom and depth of field, we can get straighter lines using the TAA method, temporal anti-aliasing, and without muting blooms down to 0. Keep in mind, for TAA methods, and TSR for that matter, requires that the spatial sample count must be an odd number. Start with 13 for spatial sample count and 1 for temporal sample count. Then, test your scene by adjusting these values. You'll be surprised to see how this low sample count as a starting point can produce better results than MSAA and TSR methods in a lot of cases. This is nice since MSAA and TSR with higher sample counts can increase renders by 100 to 200%. In a previous video, I showed how the multiplication of the spatial and temporal sample counts must be less than the R temporal AA samples variable setting. So remember to change the R temporal AA samples variable in the command console to a number that is greater than the multiplication of your 2 sample counts. Number 2, console variables. Talking about variables, we can set values for render variables directly in the render queue. The Unreal documentation posts high-quality variable settings with new releases. Make a quick search for how to use the movie render queue for high-quality renders for your version of Unreal. Click the plus sign to add a blank field. Then type the RDOT variables that Unreal recommends. You will see that you can change the render settings for motion blur quality, depth of field quality, bloom quality, tone mapping, and ray tracing. Here are some recommended starting values. What's nice is that increasing these quality settings doesn't add that much to render times. However, I'm going to recommend one variable that doesn't always show up in the Unreal documentation, and that is number 1, screen percentage. Screen percentage creates super high transitions from one line of pixels to another. We do this by rendering an image that is much higher in resolution than is being displayed, then shrinking it to the desired size using the extra pixels for calculation. It's the same idea as using a 4K image to produce 2K images instead of simply rendering at 2K. We can tell Unreal to render at 200% of the movie resolution before it downsamples to the 100% movie file resolution. 2-minute renders can become 2 hours, so use this on your final print renders. Thanks again for making it this far, and hitting like and subscribe. See ya!